Okay, so let's get into part 2 of lesson 10. And the second part is about transaction guard and application continuity. And transaction guard is new reliable protocol. This allows us to retrieve last transaction commit status. Think about that. We have a service level failure or instance failure while doing certain operations. Okay? Or if there is any communication problem, then from user point of view, we don't know whether my in-flight transaction has been committed or not, or rolled back. We have no idea. So starting with the 12c, by using Transaction Guard API, we can retrieve last transaction commit status. So if a transaction was completed or transaction was committed, then we are fine. But if a transaction never committed, then we can actually leverage application continuity. This application continuity, it allows us to replay incomplete request. So we can actually replay in-flight transaction when needed. So we can use these two nice features. Transaction Guard is a tool that provides reliable commit outcome for last transaction after errors. And we can use this API for JDBC, DIN, C, C++, and .NET. And also, application continuity can leverage a transaction guard behind the scene. Okay? So, we're going to see how we can use transaction guard, how application continuity can take advantage of a transaction guard. And the diagram, it is giving you this information. So this is in a 12c database, and also user request to work, and the database call is issued. In this database side, if there's any problem, error here, then user may not be able to receive the final message. So if that is the case, you can use the Transaction Guard API to pull out last transaction commit status information. So that is possible. So benefit of a Transaction Guard, it's very clear. So if there is something goes wrong, and in the server side, okay, we can check last transaction commit status. So we can easily make this. We can easily make decision whether we have to resubmit transaction that was rolled back, that was incomplete, or we can safely move on to another request. So that is a benefit of a Transaction Guard. So this is a Transaction Guard. How Transaction Guard works. So when you look at here, client issues submit statement, and then transaction committed in the database side. But suppose that there was a communication problem here. The client side, we have no idea whether transaction has been committed or not. So after you make new connection, and you can actually use Transaction Guard API to retrieve last transaction commit status. So this gives you a good opportunity to check your in-flight transaction status, and then you can take action after you confirm your last in-flight transaction. And these are supported transaction types: local commit, and auto commit, and commit on success. And in 12.2, two-phase XH transaction, this is not supported. And read-write database link from Active Data Guard, this is not supported. To use a Transaction Guard feature, you will have to make connection to instance by going through service where Transaction Guard is enabled. And this is a server level configuration. When you create a service, you will have to add this attribute: commit outcome equals to true. Every time when user issue transaction and commit statement, then in the database, we want to save that information for a certain amount of time based on retention timeout. And transaction guard can be used by all supported client. And this is an example of creating service for transaction guard. So here we have a commit outcome equals to true. That's one mandatory attribute. And if you have an existing service and you want to take advantage of a transaction guard, then you can use SRVCTL modify service, and you can also set commit outcome equals to true. To use a transaction guard, a DBA must grant permission properly, grant execute on DBMS app count. Now, what is your application continuity? This application continuity, it can fail over session in case of your service, the availability problem, or instance problem, or communication problem. And also, it can check last transaction commit status by working with transaction guard behind the scene. And also, if a transaction never complete, then application continuity even can replay or failed over DML as well. So application continuity, it can keep your application highly available and also support not only failover at the session level, but also it provides the transaction failover feature. And benefit is, our application continuity, it provides continuous service to the end users. And even with the outage in the server side, it's possible to fail over session and also continue to provide service by replaying incomplete transactions and also by continuing the subsequent transactions. And this is how application continuity works. If you have the application continuity supported connection pools and client like a UCP and WebLogic, OCI, session pool, and .NET, JDBC, and OCI drivers, okay? Then we can actually take advantage of application continuity. So number one, user requests a certain set of operations and database calls issued to database. And if something goes wrong in the server side, and fan message will be populated, and this will be delivered to the fan, the aware client. And especially application continuity can take advantage of a fan. So if a fan message is delivered to the connection pool, for example, then application continuity, it will take action. So first thing is, find out new location where session can be failed over. And then use transaction guard to check last transaction commit status. And then if a transaction wasn't complete, then replay incomplete transaction. If a transaction wasn't complete, then support subsequent the database calls. So that is how does application continuity work. So this application continuity works perfect in the RAG environment, and it also works in the data guard environment as well. So if you have a connection to primary database, and if there is any problem with the primary database, thus the failover occurred at that time, application continuity also can take care of the session failover and also transaction failover, just like a RAG environment. And using application continuity, so here are the supported database operations, SQL, PL SQL through transaction guard. And it works with a RAG and RAG1 node and active data guard, and also hardware acceleration on current Intel Spark chips. And also here are the supported client. In 12c, there are more supported clients available. To support application continuity in the server side, we will have to create service with a specific attribute. So first thing is you will have to enable transaction guard with a commit outcome attribute. And then you enable application continuity with a failover type transaction. And for existing service, you use in the same attribute setting. So let's take a look at this quiz. Which of the following are benefits of implementing fast application notification? A, no need for a connection to rely on connection timeout, makes sense. Used by load balancing advisory to efficiently propagate load information, makes sense. And designed for application, enterprise application and management console integration, makes sense. And D, database connection failures are immediately detected. No, actually, the failure detection is by the clusterware component, CRS. And then fan message is a message delivery. So it's not by fan mechanism. So the answer is A, B, and D. So in this lesson, I covered the two different topics. The first topic was, client-side connection time, load balancing, and failover, and also runtime load balancing, and TAF, the traditional high availability solution. And also, I covered the 12c feature, which is transaction guard and application continuity, and also new support in 12.2 from transaction guard and application continuity. And this is the second part of a lesson 10.